Everyone, welcome back to another video by Camroom 5. This video is again based on the O-level ATP examination where we will be dealing with some more planning questions. This question says a student knows the bottles contain, it starts by saying a student is provided with three unlabeled bottles. The student knows the bottles contain hydrochloric acid, aluminium sulfate, zinc sulfate. So hydrochloric acid, aluminium sulfate has this chemical formula, and zinc sulfate. The student is provided with dilute nitric acid, aqueous silver nitrate, and aqueous ammonia. So dilute nitric acid, aqueous silver nitrate, and aqueous ammonia. But no other chemicals or indicators. For each of the three unlabeled bottles, describe a test and give the observations to identify the contents of the bottle. You must describe tests that give positive results to identify the contents of each bottle. So let's begin. In order to identify hydrochloric acid, we have to see that nitric acid is useless because one acid is not going to react with another acid. Can we use silver nitrate? Yes, because hydrochloric acid has chloride in it. So we will write to identify dilute hydrochloric acid, we can take the sample in a test tube. Now you don't know which one is which, right? So you can say we are taking all three samples in test tube. So you can say we can take the samples in a test tube or samples in test tubes and add 1 centimeter cube of silver nitrate with dilute nitric acid in each, because silver nitrate with nitric acid is a test for chloride. So if we are taking the samples in test tubes and adding silver nitrate with nitric acid in each, one of the results would have white precipitate. So once these are made, we can say we label that sample as hydrochloric acid, that sample as dilute hydrochloric acid. Now moving on. Aqueous aluminium sulfate and aqueous zinc sulfate are both colorless. They are both colorless. But we know that they have different cations in them. And aqueous ammonia can help us identify them, because ammonia makes soluble precipitates with zinc but insoluble precipitates with aluminium. So what we can do is take remaining two samples in another test tubes. Now we are concerned with identification of aluminium and zinc. So take the remaining two samples in another test tubes. Add aqueous ammonia in both in excess. Don't forget to write in excess, because excess ammonia makes insoluble white precipitates with aluminium. So if insoluble white precipitates are made, we label it as aluminium sulfate. But if soluble clear solution is obtained, it is zinc sulfate, because zinc does not make white precipitate with aqueous ammonia. So to write that again, HCl with silver nitrate made silver chloride white precipitate, and the other thing was obviously the other thing was HNO3, which was our spectator ion. So I can definitely cancel on that. And what about aluminium and zinc? So we just talked about their white precipitates or clear solution in excess aqueous ammonia. Let's try this question. It says calcium ammonium nitrate is a water soluble compound. Describe a series of tests and the observations to identify the calcium, ammonium, and nitrate ions in a sample. Your description will need to explain how to prevent ammonium ions interfering with the test for nitrate ions. So first talk about calcium. To identify calcium, what do? We obviously use aqueous sodium hydroxide to identify calcium ions or calcium plus 2 ions. We add aqueous sodium hydroxide in a test tube. You need to talk about the apparatus first. So in a test tube containing the sample, you do not add the reagent into the main sample. Never add test chemicals into the original bottle, because if you do that, all of your chemical is used up, and how are you going to do other tests? So never add your testing chemicals into the original bottle. Always use test tubes. Moving on. When you add aqueous sodium hydroxide in a test tube, you receive white precipitate insoluble in excess. Those are insoluble in excess. But that does not confirm everything, right? So you can also add aqueous ammonia to confirm that. So far, based on your calcium, aluminium, and zinc, this is already confirmed. So you can say insoluble white precipitates in excess gives calcium ions as a confirmation. You don't actually have to do the aqueous ammonia test in the system. Now what will you do to find ammonium ions or nitrate ions? To test for ammonium ions, add aqueous sodium hydroxide plus heat. When you heat it, a colorless gas evolves that turns moist red litmus into blue. Now that is the test for ammonium ions. Nitrate is not tested here because nitrate gives this positive result only with aluminium foil. So nitrate hasn't been tested yet. In order to confirm nitrate, we perform a similar test but with aluminium foil also. So you will say to test for nitrate ions, repeat the test for ammonium ions but with an aluminium foil. If the gas evolves and turns damp red litmus blue, then nitrate also confirmed. I hope you guys are making a sense of it, because calcium ions in the beginning make precipitates with sodium hydroxide, which are calcium hydroxide. So aqueous calcium ions with sodium hydroxide make precipitates. Ammonium ions were tested with sodium hydroxide. So you get ammonia, which is a gas, and water if it's heated. And for nitrate ions, if you add aluminium ions or aluminium metal in the presence of alkaline medium, you receive ammonia gas. Now I'm not balancing this equation, it's not much of a concern for you guys here. Let's do one more question. That one is interesting. E150A and E155 are both brown food colorings. Plan an investigation to find whether the brown food color in a soft drink is E155A or E155. Although I should write, they sound like Elon Musk's child. But anyway, you are provided with solutions of E155A, E155 and the brown food coloring from the soft drink. You will also have access to the apparatus normally found in a chemistry laboratory. You should draw a label diagram with your plan. So I will obviously be doing chromatography here. So you can say we perform chromatography. Don't forget to mention the details. How will you do? So the steps involve: take a piece of clean filter paper. This is your chromatogram. Draw a line with pencil. Right, with pencil 2 centimeter from the edge. Now what do? That is called the baseline. So this is your baseline. What's next? So you will mention place spots of E150A, E155 and food color on baseline. What apparatus are you using here? So do mention it, that using a dropper. You can say pipette also. So using a dropper or a pipette. Then what do? We place the chromatogram in suitable solvent. Don't use water here. Water is not a universal solvent in this case, so please just say solvent, don't name water. So chromatogram in suitable solvent without immersing baseline. Then what happens? Allow spots to travel. Then measure solute front, because that is how we do chromatography. Solute front, solvent front. So solute front and solvent front, and then you talk about calculate RF value. Calculate RF value. The last step is really important. You say compare RF of food color with the reference samples. So you will find if the food color is giving you an RF equal to E150A or 155. Let me show you a very simple diagram for this. You have a piece of filter paper dipped in a jar. This is your solvent level. So this is solvent level. This is your baseline. So label it baseline. You have your spots here. They will give you your RF values like this. This is, let's suppose, E150A. This is E155, and this is your food color sample. So you can conclude from my diagram that the food color was E150A, but it could be up or down both. I hope you guys are getting how to clearly write your answers here. In the next video, we'll do some more past papers. Stay tuned, guys. Thanks.